MedCram.
Welcome to part 4 of medical acid base. I wanted to just review what we had just talked about before, in that we've got two different types of metabolic syndromes, metabolic acidosis, metabolic alkalosis, and that we've got 4 respiratory. And the reason why there's twice as many respiratories is because you have to deal with the situation where respiratory has no compensation from the kidney, and then or very little compensation from the kidney, and then chronic compensation from the kidney. Same on the respiratory alkalosis side as well. And the key point that we discovered here is that when the PCO2 and the pH are going in the same direction, either up or down, the primary pathology is metabolic. And then the opposite is true for respiratory. When we see the PCO2 and the pH, here for respiratory acidosis it's going up and the pH is going down, and for respiratory alkalosis the PCO2 is going down, the pH is going up. Again, that's a respiratory process. And what I want to do is kind of put this together for you in a nice graph, especially for those people who are spatially inclined. Let's go ahead and clear this. And I want to kind of draw a graph for you. And it's going to be a graph that hopefully you'll take with you, and you'll kind of see the utility in this. So it's just a regular graph with specifically PCO2 on the y-axis, and we'll put a middle here, which is about 40, and here pH with a middle of 7.40. Okay, and we said that there were 6 different types of acid-base disorders. So let's talk about, let's put some lines in here so we can kind of get an idea about what we're talking about. Okay, so that's that. And let's go ahead and put a line right about here. And we'll put one more line in right about here. Okay, so here's our graph. Now, we already said that if we had a situation where the PCO2 and the pH were going in the same direction, that had to be a metabolic. And so let's go ahead and label these. This one here would have to be what? Well, this line would have to represent that of a metabolic process, because the PCO2, as it's going up, so is the pH. So we know that this is, down here, a metabolic acidosis. And why is it an acidosis? Because the pH is low. So metabolic acidosis tend to push things down in this direction, whereas this must be a metabolic alkalosis. Okay, let's talk about these other ones. So these must be respiratory. The question is, which one is a respiratory acidosis and which one's a respiratory alkalosis? Well, we know that these two up here must be acidoses because, again, they're lower than the pH, and lower than pH of 7.40, and these must be respiratory alkalosis because they're higher than a pH of 7.40. Notice, though, that this one here has less play in terms of the pH. And so if you were to conclude that this must be a chronic line here and this must be the acute, you would be right, because again the chronic allows for kidney compensation and there's less shift. So this would be a chronic respiratory acidosis. And this would be a chronic respiratory alkalosis. And if we go to this one, this would be acute respiratory acidosis. And this one down here would be acute respiratory alkalosis. And you can kind of see what this is going to look like. Now let's talk about this. So as we go down here, let's talk about the metabolic acidosis first. Remember what's going on in metabolic acidosis. Bicarb is falling. And as the bicarb falls, the PCO2 is going to also fall. And when they both fall, remember the bicarb is going to fall further than the PCO2, and you're going to get a low pH. So how do you know you're dealing with a metabolic acidosis? Well, we have something called Winter's formula or Winter's rules. And let me put this in terms of an equation. And I'm going to be talking about these equations so that you could figure this out. Now, we all know that, and I'm just going to sort of write over here off to the side, that we look at the Henderson-Hasselbalch equation in terms of HCO3 over CO2, or the PCO2. And we know that things either go up or they go down, or what have you. And so what I'm going to do is I'm going to tell you, for every single point that one goes up, what does the other one do? So we know that down here, they're both going to be going down. Okay? They're both going to be going down. How much does the bicarb go down? Well, I'll tell you, for every 1 point that the bicarb goes down, the PCO2 should also go down by 1 point. And that's how you can tell that what you're dealing with there is a metabolic acidosis. What about a metabolic alkalosis? Well, things up here are actually going up. And in fact, the bicarb is going up. The ratio for up here is for every 2 points that the bicarb goes up, the PCO2 should go up by 1 point. And that's how you'll know. So what do I mean? Remember, everything starts off with a 24 and a 40. So here, what would this be? If things were to drop by, let's say, 4 points, it would be 20 over 36. Okay? Alternatively, it could also be 14 over 30. So, in other words, for every point that the numerator drops, the denominator should also drop from this. Going to metabolic alkalosis, for every 2 points that the bicarb goes up, so let's pick a number here. Let's say, I don't know, 30. It went up by 6 points. And so the PCO2 should go up by 3 points. So this would be 43. Okay, so let's go and look at the chronic respiratory situations. Let's first of all look at acute respiratory acidosis. So what's happening in acute respiratory acidosis? Remember, the lungs are not breathing. The PCO2 is going up. If the PCO2 is going up, then here our fraction is going to start from the bottom. And here, the PCO2 is going up by a lot, and we're not expecting a huge increase in bicarb. Why is that? Because it's acute. We haven't had the kidneys the chance to kick in. So here the ratio is 10. For every 10 points that the PCO2 goes up, the bicarb only goes up by 1 point. And so what would be a good example here? A good example here would be, for instance, if this was 50 on the bottom, and this would be 25. That would be acute respiratory acidosis. What about in chronic respiratory acidosis? Again, same situation. We have a fraction. However, because the kidney is now kicking in, we are expecting to see less of an increase in CO2 without the kidney kicking in. And here, it's for every 3 points that goes up on the PCO2, the bicarb goes up by 1 point. So something that we would see here, let's say we had the same kind of ratio. Let's say we had 49. Okay, that would be 9 increase for every 3. That would be 3 of those. And so we would add 3 to that. That would be 27. Okay, because 4 to 49, that's 9 points. 9 divided by 3 is 3. 3 times 1 is 3. We add 3 to the 24. We get 27. And that would be the new ratio. And that's how we can tell. Let's go down to these again. Chronic respiratory alkalosis. Here, the ratio. Actually, let's go to acute respiratory alkalosis. Remember here what's going on. the lung is blowing off a tremendous amount of CO2 and the kidney has not had a chance to kick in. So for every 5 points that the CO2 drops by, the PCO2 drops by, the bicarb is going to drop by 1 point. And so let's look here. Let's say that a good example would be, let's say that the PCO2 dropped to 30. Okay, that would mean that the bicarb would drop down to 22. Okay, if you're doing your math right. And then similarly over here, chronic respiratory alkalosis, here the kidney has been allowed to kick in, so we're not going to get as much CO2 drop per drop in bicarb. And so here the CO2 is dropping again, but for every 2 points that it drops, the bicarb goes down by 1 point. And so what that would mean? Again, if we had a ratio, an example where the PCO2 had dropped down to 30, that's about going from 40 down to 30. For every 2 of those would be 5, so we drop by 5. That means that our bicarb would then be about 19. So again, these are ratios. For every one that the bicarb, for every one that the bicarb drops here, the PCO2 drops by 1. And so these ratios here, the ones that I'm circling, these here are ones to know for each of these different types of categories, because it will help us later identify if something else is going on. Okay, these are the characteristic signatures of these type of processes, and there are 6 processes. These are sometimes known as Winter's formula. These are ones that I've kind of made up. For the 6 here, we've got metabolic acidosis, metabolic alkalosis. We've got acute respiratory acidosis, chronic respiratory acidosis, chronic respiratory alkalosis, and acute respiratory alkalosis. And so those are the rules. Great. So I think the basic points here were understood. This concludes part 4. We're going to put everything kind of together and show you how to attack an acid-base problem and put it all together through a systematic step in part 5. So please join me for part 5, and we'll kind of review everything there. Thanks.